Mr. Auerbach, and I'm here to talk to you about the periodic table, and specifically periodic table and atomic structure, and even more specifically, talking about the attraction between the nucleus, protons, and electrons that go around the atom. So sometimes electrons are very strongly attracted to electrons. Here I am picturing trying to pull them apart. And sometimes they're very weakly attracted. Bloop, they just pop right off. And a lot of why that is has a lot to do with where they are on the periodic table. So that's what I'm going to talk to you about today. And let me switch pages here. So one of the ideas that's really important here is this idea of valence and core electrons. Now I know we've talked about this, but we're introducing the vocab term of core electrons, which are the electrons on the inside. So in this we have neon, which has 1, 2, 3 energy levels. Here you have your 1s electrons, here you have your level 2 electrons, and here is your single third level electron. And so the blue colored ones, the 1 and 2 level, are the core. The valence are the ones touching the outside. No, the valence are the farthest ones out, and those are the ones that interact with other atoms and the world. And so they turn out to be very important, and they have a lot to do with the properties of an element. So now that we have that out of the way, I want to move on and talk about, well, Coulomb's law I'm not going to talk about. I'm going to talk about that separately. Basically, the idea of Coulomb's law is that the more difference there is between the charges of two particles, like if one is a positive 2 and the other is a negative 2, they'll be attracted to each other. But if one is positive 4 and the other one's negative 4, that great big difference in attraction makes them even more tightly attracted. That's Coulomb's law. And also, the closer things are that are oppositely charged, the more attracted they'll be. That attraction goes down exponentially as you separate things. That turns out to be important too. We'll talk about that in a minute as it relates to our electrons.